Hello everyone. Today we are going to discuss what are the different one-mark questions regarding electrical and electronics engineering in the first year level. Let's start our session. Yeah, coming to the Ohm's law, at constant temperature, voltage across an element is directly related to current flowing through that particular element. V is equal to IR. It's not applicable for nonlinear elements and unilateral elements. These are the two limitations. KCL stands for Kirchhoff's current law. Sigma stands for algebraic sum of all the currents meeting at a junction or node is equal to 0. That's it. KVL stands for Kirchhoff's voltage law. The algebraic sum of all the voltages in a closed path is equal to 0. This one comes from law of conservation of energy. This one comes from law of conservation of energy, whereas this one comes from law of conservation of charge. Yeah. Yeah, coming to series and parallel connection. In series connection, the current is almost same. The voltage will divide, and the equivalent resistance here is R equivalent equal to summation R1 plus R2 plus R2, so on like this. In terms of parallel connection, 1 upon R equivalent is equal to 1 upon R1 plus 1 upon R2 up to so on like this. If you come across any numerical, just write these formulas so that you can gain some marks in examination point of view. Coming to superposition theorem, in any linear active bilateral network, the response in any element is equal to algebraic sum of responses caused by individual sources acting alone. That is, voltage to 0, it's nothing but short circuit, and current to 0, open circuit. Yeah, we can calculate both for response in the sense voltage or else current. For the sinusoidal standard voltage equation and current equation format here is V equal to Vm sin omega t, I equal to Im sin omega t. These are the current and voltage equations. Angular frequency omega is equal to 2 pi f. F stands for frequency. It's 1 upon time period. T stands for time period. And units here, hertz or cycles per second. Yeah, this one, the unit for the angular frequency, radian per second. This one is the sinusoidal voltage waveforms and current waveforms here. The voltage waveform is a yellow colored one and the green colored one is current waveform. There is a difference here. The difference may be called it as phase difference phi. Yeah, this one is a phase difference phi in between these two waveforms. And we clearly observe that voltage is leading the quantity of current by an angle of how much? Phi. This phi stands for phase difference in between these two waveforms. In order to complete one complete cycle, that it is one positive half and negative half, that may be called it as time period. When I know the time period, when you go for frequency, it's nothing but reciprocal. Just relation. The maximum value is nothing but it's a Vm or peak value Vp. From maximum positive peak to the negative peak may be called it as peak to peak voltage. Yeah, these are simple definitions from sinusoidal waveform. And we can have some simple derivations regarding the part of root mean square Vrms and V average. Yeah, you can write both the things here, Irms or else I average. But I can change it as 2 Im by pi. Whereas this one is Im by root 2. Im stands for maximum value. Yeah. Form factors, these two are factors. There are no units for this particular one. It's a ratio now. RMS value, form in the sense RMS value to average value ratio. Peak in the sense peak value to RMS value. And these are two are the standard values for sinusoidal voltage equation or current equation. These two are impedance triangle, power triangle. Impedance triangle is nothing but resistance. X stands for reactance. Z stands for impedance. The units for all these three parts are ohms only there. Yeah, Z is equal to R plus JX. Don't neglect this one. Yeah, power triangle is nothing but we can in terms of three powers. S is equal to P plus JQ. S stands for total power. P stands for active power. Q stands for reactive power. Vi cos phi is for P. Vi is for the total power. This one is for the part of Vi sin phi. Coming to the power factor, it's just an angle in between voltage and current. Or else we can call it as cos phi is equal to R by Z. Another one in terms of power triangle, cos phi is equal to P by S. These are the phasor representations for the resistor, inductor and capacitor. For the part of resistor, both voltage and current are in phase. Is there any angle? It's obviously 0. What's the power factor here? Cos 0 is equal to 1. What about this particular L here as VIL? Voltage leads current in a pure inductor. That it is, voltage leads current by an angle of how much? 90 degrees. Whereas this one, current leads voltage by an angle of how much? 90 degrees, CIV. Remember the formula here, civil. That's it. And the power factor for L and C here is 0. Cos 90, it becomes 0. Cos stands for power factor. These phasor representations is nothing but they can represent with the line segments. Voltage and current relations there. Coming to the second unit, it's a DC machines and we can have some generator motor principles. Remember this generator principle, Faraday's law. E equal to minus N d phi by dt. E stands for induced EMF. N stands for number of turns. And phi stands for flux. T stands for time. And the direction is given with the help of Fleming's right hand rule. Whereas for the motor, F equal to Bill sin theta, torque equal to force into perpendicular distance. B stands for magnetic field, I stands for current, L stands for length of the conductor. This law may be called as Lorentz force law. The direction is given by Fleming's left hand rule. Transformer works on the principle of mutual induction. Behind the part, they can use only Faraday's law. Whether it's an AC generator also, Faraday's law. Whether AC or DC depends upon the supply. The law doesn't change and the principle. Coming to the applications point of view of electrical machines, we can use it anywhere here, industrial point of view, domestic point of view, transportation sector, medical sector, research and development, aerospace, defense, construction, mining, everywhere we can use it electrical machines, generator, motors, everything. We can use it in cranes, elevators and lifts, everywhere. Three-phase induction motor works on the principle of we can use it electrical supply as input that it has three-phase. IR, IY, IB. Induction means Faraday's law. E equal to minus N d phi by dt. Motor means Lorentz force. F equal to Bill sin theta. Torque equal to force into perpendicular distance. And don't forget the thing. Ns synchronous speed is equal to 120 F by P. And slip is equal to Ns minus Nr. Percentage slip in the sense by Ns. Alternator or AC generator is it's also a generator here. It works on the principle of Faraday's law only there. Remove that commutator. We can have some two main parts there, stator and rotor. That's the only variation. Remaining everything is common there. Measuring instruments, in order to measure voltage and current, we can have some two categories, PMMC and moving iron. And in order to measure resistance, we can have some Wheatstone gauge. MC is only used for DC supply, whereas MI, we can use it for both AC as well as DC. For the construction point of view, and we can have some mandatory parts here as these three torques: deflecting torque, controlling torque, damping torque. Deflecting torque is equal to controlling torque. This one is a equilibrium condition. Remember this line. This condition is the main. Coming to the types of transformers, step up and step down, we clearly observe that the number of windings in the primary N1 is obviously less than N2. That type of transformer may be called it as step up, low to up, step up. From up to down, we may call it as step down. That's it. Coming to the energy sources, we are having some renewable energy sources, non-renewable. Renewable in the sense, we are having some solar, wind. It's a pollution free. Whereas we can have some non-renewable, exhaustible. After some days, we can't see these particular non-renewable. Nuclear, coal, oil, natural gas. It creates pollution. Unit. 1 unit of electrical energy is nothing but I know the power formula is equal to work by time. From that, what's the value of work? Power into time. The power units are kilowatts into hour. How much amount of power we can consume within a duration of 1 hour of time may be called it as 1 unit. That's the only thing. Don't forget 1 unit is equal to 1 kilowatt hour. Yeah, let it be we are having some, I am having a rating of 1000 watts of fan. I can use it for 5 hours of time. And how many units in the sense? 1000 into 5 divided by 1000. We can have some how many units here right now? 5 units. That's the only thing. Multiply those things, we get this particular unit. Tariff in the sense the rate at which electrical energy is supplied to consumers. Yeah, the rate at which electrical energy is supplied to consumers may be called it as tariff. In this, we are having some two-part tariff also there. Two parts, fixed charges and running charges. Yeah, whether we can use it or not, we have to pay these fixed charges. Running charges in the sense how much amount of electrical appliances we can use it, that it is used for the part of running charges units. Coming to the protection point of view, we can having some miniature circuit breaker MCB and fuse. Fuse, every time you have to replace this particular thing. Whereas miniature circuit breaker MCB, automatic, it can trip and automatically it can on there. For the protection of electrical appliances. Electrical appliances, I can use it some sort of MCB as well as fuse. What is meant by electric shock? It's a sudden discharge of electricity through a part of the body when it is contacted to electrical appliances. That thing, instantaneous discharge of electrical energy takes place by transforming charges directly to the earth with the help of low resistance wire. We can easily save this particular human being by creating one low resistance wire. We are having some different types of earthing, pipe earthing, plate earthing, rod earthing. We are having some earthing surrounding parts. We can fill it out some sort of sand. We can have some rock material. We can have some salt. Yeah, sand, rock, everything. We can pour in there, water also. Coming to the electronics point of view here, diode symbol is a crucial part, anode and cathode. These are the two things. It operates only in forward bias, whereas Zener diode, we can operate in reverse bias. That's why we may call it as Zener diode will have some application. It can use it as a voltage regulator, maintain some constant voltage. Application of PN junction diode, it uses it as a part of rectifier. Zener effect, yeah, remember without creating any damage, the breakdown voltage of voltage can occur at a specific voltage. It can't create any damage to the diode. That type of effect may be called as Zener effect. These are the symbols for PNP and NPN. And don't forget the thing, emitter base collector, IE is equal to IB plus IC. Remember that equation. PP, no, arrow mark is inside the things, arrow mark is outside the part. These are the symbols for PNP and NPN. Depends upon space wise, collector occupies large space compared to base and emitter. Base is the least space, whereas emitter is a large space. In terms of highest electrons, it emits emitter. Rectifier stands for which converts AC signal to DC. This DC may be called as pulsating DC. Filter, again this pulsating DC, we can make it to almost the constant DC, maybe call it as we can use it one capacitor filter or inductor filter. Amplifier, we can use it in terms of which thing here? Mic sets. Yeah, it's a device which strengthens the weak signal to strong signal. When I speak some low voice, it obviously rises the signal to higher level. Yeah. Transducer, which converts one form of energy to another form, that it may be physical to electrical signals. Types of number systems, binary, 2 suffix, octal, 8, decimal 10, hexadecimal 16. This is one is the AND symbol there. Yeah, obviously we are having some D. This one is the R symbol. Cut it out and we can have some symbol maybe like this. 2 inputs and 1 output. Yeah, use of parity bits. We can use it in terms of data transmission. Error correcting codes is obviously maybe call it as Hamming code. Distributive law, A into B plus C is equal to AB plus BC. Types of flip-flops, you already know that SR, JK, D, and T. T stands for token, SR stands for set reset. Registers, group of flip-flops storing multiple bits may be called it as registers. Counters, sequential circuit counting pulses may be called it as counters. Yeah, remember all these are some basics. We can recollect some other basics also there, but in examination point of view, this plays a crucial role. Yeah, thank you for your patience listening.